In this session, we're going to be talking about some of the common types of chemical reactions you will see in chemistry. So let's start out with the first one. The first one is called a synthesis or a combination reaction. So as the name specify, you have two elements or two smaller reactants and they combine on to make something bigger. So that's why it's in a synthesis or in a chemical reaction, synthesis or a combination reaction. So a typical example of a synthesis reaction I can write as N2 combining with H2 and it goes on to make NH3. So you can see you have two smaller reactants and they combined together to make something bigger. And you also must balance the equations. So when you're balancing these equations, you have three in front of the hydrogen, but you have two hydrogens, so they're not multiple of one another. So you will have to put three in front of the hydrogen there to make a total of six hydrogens. And then when you do so, you will have to put two in front of the ammonia or NH3, and that will take care of and that will take care of all the atoms being balanced. If you have hard time balancing equations, I have another session, another tutorial that just specifically talk about balancing equations of different types. So make sure to watch that one. So that's your synthesis reaction. So two small things make something bigger. The next one is decomposition reaction. The decomposition is actually opposite to the synthesis reaction, where you have something big and it gets broken down into smaller species. So AB gets broken down into A plus B. And in this particular case, if I take an example of calcium carbonate, the calcium carbonate, when it's heated, it gets broken down into calcium oxide and CO2. So you have a big chemical and it gets broken down into two smaller chemicals. And when I look at balancing the equation here, seems like everything is already balanced. You have three oxygens on both sides, and you got one carbon on both sides and one calcium on both sides. So that's already balanced. But let me take another example. So suppose I have hydrogen peroxide, so H2O2, and that goes on to make H2O plus oxygen. Okay, so if I want to balance this particular equation, so this is obviously a decomposition because you are breaking some bigger chemical into two smaller chemicals there. So when I want to balance this, um, worry about balancing the oxygens because it seems like you have one oxygen here and two oxygens here, so that's a total of three oxygens, but you really can't have three oxygens on to the reactant side. The only thing you can have is at least you can put in and as a coefficient would be 2. So that's going to be 4 oxygens. And how would you make 4 oxygens on the product side? Well, you can go ahead and put 2 in front of water and that will take care of all the oxygen. So you have 2 oxygens here, 2 oxygens here. That makes 4 oxygens total. Okay, so then you have the single replacement reaction where a generic reaction would look like AB reacting with C, and that goes on to make CB and A. So what really happens here, you have one of the chemical swaps there, or one of the elemental swaps there, which with the C, and the other one stays by itself. So that's why it's in a single replacement reaction. So let me take a simple example. Suppose I have zinc sulfate, and that reacts with copper solid. So zinc sulfate is going to be aqueous, and as in a product, the copper goes with the sulfate now, so that's why there's going to be a swap between one side of the chemicals there. So it's going to make copper sulfate aqueous and zinc solid by itself. So that's one type of single replacement reaction because you have only one, either the cation or the anion being swapped with the other chemical in the reactant. Okay, so then you can have the double replacement reaction. So as the name specifies, the difference between the single replacement and double displacement, you'll have two swaps in double displacement. So suppose I have AB reacting with CD, and that goes on to make AD plus CB. Okay, so one of the tricks you can always use when you're doing the double displacement reactions, in order to, later on you will be learning how to predict the products, is whatever the inside is stays with the inside. So another way of saying this, B will get combined with the C here, and then the outside stays outside. This A get combined with the D. So that's why you make AD and the CB is your products there. So let me take an example. Suppose I have NaCl reacting with AgNO3. Both of those going to be aqueous. Okay, so when we're looking at the products, they're gonna swap where the inside stays inside and the outside stays outside. And obviously, if you wanna, we'll talk about how you're gonna be predicting the products in a different session. But just as a rough idea, the inside stays inside and the outside stays outside. So silver gets combined with the chlorine here. It makes AgCl solid, and then sodium gets combined with the nitrate here, so that's going to make NaNO3 aqueous. So what the actual formula is going to be, whether you will have to worry about putting any subscripts, that has to do with what charges these chemicals going to have. So I'll have a separate session where I'll just talk about the prediction of a double displacement reactions. In this particular session, you just want to make sure you're able to identify the different types of reactions when you're asked to do so. Okay, so then this last one is called a combustion reaction. The combustion reactions are actually relatively easier to pick. It's always going to have a hydrocarbon, which means you're going to have a chemical that's made of carbon and hydrogen, so CH4, and occasionally you may have like oxygen in there as well. Another way of saying more or less an organic compound. Plus, you must have an oxygen on the reactant side to make this in a combustion reaction, because remember, when you're burning something, it's always being burned in the presence of oxygen. And one of your products is going to be carbon dioxide, and your other product is going to be water. So that's those are the typical combustion reaction products. Are you always going to have an oxide, and sometimes depending on the reactants you may have the water as well. So this when I balance this equation, I want to make sure I have the correct number of oxygens and carbons. So it seems like I have 4 hydrogens on the reactant side, so it needs to have 4 hydrogens on the product side. So you can put 2 in front of the water, and that will make how many oxygens on the product side? You have 2 oxygens on CO2, 2 oxygens on water, so that's 4 oxygen atoms total on the product side. So you can go back and put 2 in front of the oxygen to make a total of 4 oxygens. So that's in a combustion reactions. When you're doing the combustion reactions, it's mostly you're dealing with hydrocarbons. A lot of books is just specifically classify hydrocarbons being burned in the presence of oxygen as in combustion reactions. Some books may say, for example, what if I have carbon burning in the presence of oxygen and it's making carbon dioxide? Yes, it is in a combustion reaction as well, but at the same time, this could also be classified as in a synthesis reaction. All right, along with being in a combustion reaction. Okay, so that's just because you are burning something in the presence of oxygen and you are making some sort of oxide, in this case carbon dioxide, but at the same time you are combining 2 smaller elements or 2 smaller chemicals here to make something big, so it's also in a synthesis or a combination reaction as well. But like I said, for the most part, a lot of books just classify the hydrocarbons being burned in the presence of oxygen as in a combustion reaction. But like I said, don't forget the burning of carbon could be classified either the combustion reaction or the synthesis reaction as well. All right, so those are the 5 types of chemical reactions you have to worry about when you're taking especially in an introductory chemistry course. If you have any questions, feel free to leave any comments in the section below.